For our final example, we want to solve the tangent of 3x plus the secant of 3x equals 2 over the interval 0 to 2 pi. This is a good news, bad news situation. The good news is the angles are the same. The bad news is the angles are 3x, which means at some point I'm going to have to generate 3 revolutions, right? Okay, worse news. I have a tangent and a secant involved in this problem, and the only way to handle those is to isolate the secant and square both sides. Let's do it. So if I'm going to leave the secant, I would like him by himself because he's easier to get rid of. So I'm going to move the tangent to the other side and keep secant of 3x is equal to 2 minus tangent of 3x. And then I'm going to square both sides. And when I square secant, I get secant squared. And I'm going to FOIL this out. I'm going to do it in my head. It's probably going to stress you a little bit, but it's okay, because I'm going to square double square it. If I square the first, I get 4. If I take the product of the 2, I get negative 2 tangent of 3x, and I double it, I get negative 4 tangent of 3x. And then if I square the last, I get a negative squared is a positive tangent squared of 3x. Which looks much, much worse than what I started with, but it will now allow me to replace secant squared with 1 plus. What will it allow me to replace secant squared with? 1 plus tangent squared. That's my Pythagorean identity. So this will be 1 plus tangent squared of 3x, is equal to 4 minus 4 tangent of 3x plus the tangent squared of 3x. And the only nice thing at all so far about this problem is that the tangent squareds now zero out when we subtract one from one side, right? Okay, so they're gone, and we are left with 1 equals 4 minus 4 tangent of 3x. And unfortunately, even if I get that equal to 0, it won't factor. Oh, we don't need it to factor, do we? It's a single trig function. We just need to isolate it. So we need to subtract 4 from both sides and then divide by negative 4. Okay, let's do that. If I subtract 4, I have negative 3 equals negative 4 times the tangent of 3x. Divide by negative 4, and I see that tangent of 3x actually has to equal positive 3/4. So things are looking up until we realize that's not on our unit circle. And we're in radian mode, so we're going to have a bunch of decimals running around. So next, I need a reference angle. How do you find a reference angle where the tangent of something, in this case 3x, is 3/4? You use your calculator to do the inverse tangent of 3/4, and that will give you your reference angle. So the inverse tangent of 3/4 gives me a reference angle of, and guys, I am only going to 4 decimals because I worked this at home using 7 or 8 and I almost went crazy. So just give me the 4th decimal place in radian mode of the inverse tangent of positive 3/4.
36.
You're in degrees. Go to radians.
0.6435.
0.6435. So my reference angle is 0.6435. That's going to be the most important number I come up with. Okay? 0.6435. Now I have to move that to the appropriate quadrants for 1 revolution. Okay? So for 1 revolution, tangent is positive in quadrant 1, which is good, and quadrant 3, which I need, right? Okay, so the quadrant 1, I think I'm going to, let's do it right now. Quadrant 1 is 0.6435, and how do we move it to quadrant 3? You do pi plus that, right? So guys, find pi plus that answer and give me the quadrant 3 angle. $3.7851. You guys all agree on that? Okay. So there's a quadrant 1, there's a quadrant 3. That is 1 revolution. How many revolutions do I have to go? 3. I have to go 3 revolutions for this guy. So so my 3 revolutions, I know, are going to start with those. That's my first one, 0.6435 and 3.7851. And how do I find a second revolution? What do I add to both of those? Stay with me, guys. I know this is awful. You add 2 pi to both of those, and that will give you your second revolution. So this is revolution 1. Okay, add 2 pi to those. Do we need to pause and give you a second to catch up on your calculator? Okay, let's pause. Okay, so we added 2 pi to both of those. I actually think I'm going to rearrange these because I'm running out of room. I'm going to write them beneath it. Okay, so that's my first revolution. My second revolution gave me 6.9267 and 10.083. I can't write. Excuse me. Did you guys get 0.0683? Check me. Is that the second revolution? Okay, now how do I find the third revolution? You add 2 pi to each of those again.
Why do that means?
I don't know.
Because then don't we have to go through and divide all these by 3?
Yes, ma'am. Yes, you do. Thank you for pointing that out. You do. Okay, so the next one is 13.2099. And the next one is 16.3515. Okay, there are the 6 things that 3x can equal. But that's not even anywhere near my answer. I now have to divide every one of those by 3. So we're going to go through, we're going to divide all of those by 3. And we're going to have that x equals, there's going to be 6 different things. 1, 2, 3, 4, 5, 6. So I'm going to pause and I'm going to let you divide them all by 3. Okay, so when we divide them all by 3, we get 0.2145, 1.8799, 2.3089, 3.9743, 4.4033, and 6.0687. So there are our 6 alleged answers. You want to hear the worst part?
Yeah.
You remember when we squared both sides? That means we now have to check. I know, it's almost comical. Now we have to check for extraneous solutions. But here's the good news, you guys. You only have to check one revolution. If one of them is extraneous from the first revolution, everything after that was generated off of it is extraneous as well. Okay, so you only actually have to check these first 2. Okay, so we're going to pause. I want everybody to check those. We're going to see if they work. And they need to equal approximately 2 when we plug them in. So apparently I can't divide by 3. Is that what you're telling me? What should this be?
1.2617.
1.2617. Thank you. Oh yeah, that doesn't, okay, thank you. Okay, did anybody check the first one yet? 0.2145? You need to be in radian mode. The first one works, okay. Because the first one works, that means everything that was generated from it will also work. So the good news is you only have to check that first revolution there, okay? So if we check 0.2145, the 2 that we added 2 pi to get from it, they will also work. And has anybody checked the 1.2617?
I came out with an error.
It doesn't work. Yeah, I've tried it 2 or 3 times. It doesn't work. It didn't work the other time either, but that was the wrong answer apparently. But let's I guess we better like really check it. You got an error? I don't think it works. Somebody else check it. We'll pause again. So when we type in the second one, we do tangent of 3 times 1.2617 plus 1 over cosine of 3 times 1.2617. that ends up equaling negative 2 something, right? We want it to equal approximately positive 2. So it doesn't work. So none of these work either. So the only 3 answers are those guys. And that's the end of chapter 6.